Okay, let's start Unit 2. This is the first topic, 2.1, change in arithmetic and geometric sequences. For each of the following, we have to determine the sequences, arithmetic, geometric, or neither. So uh, we should know, if we start solving this worksheet, that for arithmetic, the difference should be same. For geometric, difference between consecutive terms. Likewise, in geometric, ratio between consecutive terms should be same, and if that both of it doesn't happen, then it's neither. So let's find the difference. It doesn't look like a ratio, right? Sometimes just you can make a intuitive guess. For example, here it feels like it is a ratio. This looks more like a difference. So let's find 7 minus 5, 7 minus 12. 7 minus 12 is negative 5. 2 minus 7 is negative 5. Negative 3 minus 2 is negative 5. Negative 8 minus minus 3 is negative 5, and so on. So yeah, this is the difference is same. So this is arithmetic sequence. Here we can see that the ratio is actually same because 10 divided by 5 is 2. 20 divided by 10 is 2, 40 divided by 20 is 2, and so on. So this is a geometric sequence. Here also it looks like a ratio. 10 divided by 20 is obviously 1/2. 5 divided by 10 is also 1/2. So 10 divided by 20, 5 divided by 10, 5 over 2 over 5. So this is 1 over 2. This is 1 over 2. Here 5 and 5 is gone. And on the top I have 1 over 2. So you understand that 1 over 2 over 1 is just 1 over 2. I basically use keep, change, flip. So this is also a geometric sequence because the ratio is same. Okay, this one looks like a difference probably. So 1 minus 1 over 3 is, I think, 2 over 3. Then 5 over 3 minus 1 is, well, 2 over 3. 7 over 3 minus 5 over 3 is, well, 2 over 3. 3 minus 7 over 3 is 2 over 3. Interesting. So it is actually an arithmetic sequence. You must have noticed that I'm doing latter minus former, right? So you have to maintain the same sequence because this habit is going to help you later on. So always is latter minus former or latter over former if you are doing the geometric. Okay. This is a neither. I know that because this is called Fibonacci series. It's a very popular series where if you notice the first two terms, those are 1, 1. Now the third term is basically the sum of the previous two terms. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13. So this is actually neither. Neither it is following a common difference or a common ratio. This one is interesting. Question 6 has two ways to do it. Bn. So either you can find Bn plus 1, which is the immediate next term, by replacing n with n plus 1. So it is n plus 1 plus 3 over 2, which can be written as n plus 4 over 2. And probably you can try to find a difference. I mean, it feels like the difference will be same. So Bn plus 1 minus Bn will be equal to n plus 4 over 2 minus n plus 3 over 2. Make sure to put a parentheses. So here we have over 2. So this will be n plus 4 minus n minus 3. So these two are gone. And 4 minus 3 is 1. So we have 1 over 2. So the difference is same because that's a constant, right? It's not dependent on n. So it means this is an arithmetic sequence. The other way is, if you're not comfortable with the n method, just put n as any random number, probably 1. Let's find b1, which will be 1 plus 3 divided by 2, which is 4 over 2, which is 2. Let's find b2, this will be 5 over 2. Let's find b3, it will be 6 over 2, which is 3. Let's find b4, it will be 7 over 2. Now, if you notice the pattern, to 5 over 2 is eventually of course 2.5, right? So 2.5 minus 2, difference is 0.5. 3 minus 2.5, again 0.5. This is 3.5. So 3.5 minus 3, again 0.5. So yeah, difference is same. So this way also it is arithmetic sequence. It depends on which one you want to go with. Green is more generalized in nature. Right. This is on arithmetic. So we are given some information. We need to find an expression for a sub n and then find a11. So the formula that I will be using is an will be equal to a1 plus n minus 1 times d. right? That's the formula that I will be using, where A1 is the first term and D is the common difference. And for D, I'm going to use a slope formula because after all, arithmetic has a common difference, right? And common difference is also a property of a straight line. So you can treat these points, these well, sequence values as points. Like 3 comma 7 is a point on a straight line and 8 comma 17 is a point on a straight line. So for common difference, I will just use y2 minus y1 over x2 minus x1, which is obviously we are aware of that. It's a slope formula. So that actually saves time. So I'm going to use D formula over here, which is y2 minus y1 over x2 minus x1, which is 10 over 5, which is just 2. So this is the common difference. And now I'm going to use this equation and any number, honestly, of your choice, whichever you. I would like to take small numbers, of course. So 3 comma 7. So if you put 3 comma 7 here, it's going to look like, okay, I'll just put n as 3. Perhaps that will make more sense. So I will put n as 3 here because I'm talking about n as 3, a3. So a3 will be equal to a1 plus 3 minus 1 times d. So what is a3? It's given in the question as 7. a1 I don't know. 3 minus 1 is 2 and common difference is also 2. So 2 times 2 is 4 and 7 minus 4 is 3. So 3 is equal to a1, or a1 is 3. And that's it. I have my formula because now my answer will be an will be equal to a1 that I have 3 plus n minus 1 times the common difference is 2. If you want, you can open this up. 3 plus 2n minus 2, which will look like 1 plus 2n. And they also need A11. So A11 is going to be 1 plus 22, which is just 23. So A11 is 23. That's what we have. All right. I think you should be okay to try question 3 now. All right. Once again, I'm going to use the same common difference formula, which is going to be y2 minus y1, which is negative, and just be careful with the double negatives here. Negative 9 minus minus 3 over 6 minus 2. So that's going to look like negative 6 over 4, which is negative 3 over 2. Well, an unpleasant number, but yeah, not that much. Okay, now I'm going to use probably this one. So I will say A2 is equal to A1 plus 2 minus 1 times D. A2 is negative 3, A1 I don't know, 2 minus 1 is 1, and D is minus 3 over 2. So adding 3 over 2 both the sides, this is how it looks. So A1 will be equal to minus 3 over 2. Okay. I think I have this, but I need more space. So I will say that AN, my final conclusion over here is A1 plus n minus 1 times D. So A1 is negative 3 over 2. Well, that's pretty interesting. A1 and D both are same. Wow, excellent. N minus 1 times negative 3 over 2. If we open this up, it will be negative 3 over 2 minus 3 over 2 and plus 3 over 2. These two are gone. So an is equal to negative 3 over 2n. And they were looking for, I think, a11, right? So a11 is going to be negative 3 over 2 times 11, which is negative 33 over 2. Well, I hope I've not made any mistakes, so that should be our answer. Okay. Oh, well, this is so nice. Common difference is already given to us. So I'm just going to right away say that an is equal to a1 plus n minus 1 times d. I will put n as 5. So a5 is equal to a1 plus 5 minus 1 times d is negative 4. A5 is 7. So 7 is equal to a1 minus 16. Adding 16 both the sides. This is 23, right? Yeah, yes, of course. Okay, so this is 23, and that's about it. I think my answer is an is equal to a1 plus n minus 1 times negative 4. So 23 minus 4n plus 4. So this will be equal to 27 minus 4n, that is an. And a11, of course, a11 will be just plugging in n as 11. So that will be 11 times 4 is 44, and 27 minus 44 is negative 17. Negative 17, yeah. Right, so I'm just gonna box these in. These are our final answers. Okay. The next one is also similar. It's just fractions, so may not be pleasant. Uh, I'm going to use again a, and basically I'm going to use the same equation and plug in the numbers. So a4 will be equal to a1 plus 4 minus 1 times d. a4 is negative 1, a1 is this, 3 is this, d is 2 over 3. Well, that's nice. 3 and 3 is gone. So negative 1 is equal to a1 plus 2, which means that a1 is actually negative 3. All right. If we have A1, I think we have our final conclusion as well, because uh, so I'm going to write that AN will be equal to A1 plus N minus 1. N minus 1 times D is 2 over 3. So this will be negative 3 plus 2 over 3 and minus 2 over 3. So this will become, I think, negative 11, right? Negative 11 over 3 plus 2 over 3, and that is A sub n. Okay, A11. A11 is just replacing n with 11, so that will be 11 times 2 is 22. Fortunately, they have common denominators, so 22 minus 11 is 11, so that's just 11 over 3. Okay. Right. Well, this is different. They have given a graph to us. You might be a little surprised that how can there be a zeroth term? I mean, think about it in terms of straight line, right? That will make sense to you. So I always think about it in terms of straight line. I know that I have to find slope to find the common difference. So let's take any 2 points as the slope, 0 comma 10, and this is 1 comma 7. It means that a1 is 7, by the way. So the difference will be y2 minus y1, which means that 7 minus 10 over x2 minus x1, which is 1 minus 0. So negative 3 over 1, which is negative 3. So an will be equal to a1 plus n minus 1 times d. a1 is already 7. N minus 1, we don't know, and d is negative 3. So if we open this up, it will look like a7 minus 3n plus 3, which will become 10 minus 3n, right? Which will become 10 minus 3n. So that's the a sub n. We need a11, of course. So let me just mark that as a sub n. All right. Okay, a11 is going to be replacing n with 11. So 33, 10 minus 33 is negative 23. So these are the final answers. Likewise, over here, we are given the x coordinate as 2, y coordinate is 4, x coordinate is 5, y coordinate is negative 3. So the slope is going to be y2 minus y1 over x2 minus x1. So this is negative 7 over 3. Cannot be simplified, so that's about it. And a2 is given as 4. a2 is given as 4. So I'm going to use that a2 and the common difference to find a1. So an is equal to a1 plus n minus 1 times d. N is 2 because we know a2. So a2 is a1 plus 2 minus 1 times d. a2 is 4, so 4 is equal to a1, we don't know. 2 minus 1 is 1, and d is negative 7 over 3. So it will be 4 plus 7 over 3 is equal to a1, which means that a1 is 12 plus 7 is 19 over 3. All right. If this is a1, then what will be the equation? Equation will be a sub n will be equal to a1, which is 19 over 3 plus n minus 1 times common difference, which is negative 7 over 3. Let's open this up. So this will become 19 over 3 minus 7n over 3 plus 7 over 3. 19 plus 7 is 26. 26 over 3 cannot be simplified, so it's just 26 over 3 minus 7n over 3. This is an. They need a11. I'm just going to replace n with 11. So a11 will be equal to 26 over 3 minus 77 over 3. And 26 minus 77 is negative 51 over 3. And well, it looks like it can be simplified. 3 times 1 is 3. 3 times 7 is 21. So negative 17, that's the value of A11, right? Okay. Likewise, we have three similar questions for geometric sequence. The formula that I will be using is Gn is equal to G1 times common ratio raised to n minus 1. Yeah, and yeah, that's about it. So, well, that's pretty straightforward because everything is given. So Gn will be equal to G1, which is just 5, and R, which is just this. So 5 negative 2, I'm just putting parentheses because it is a negative number, raised to n minus 1. This is G sub n. And G11 is, sorry, they need G6. So G6 is going to be 5 times negative 2 raised to 6 minus 1, which is 5 times negative 2 raised to 5. It's fine. I'm just going to leave it like that. But it will be a negative number 2, 4, 8, 16, 32. Okay, it's not that bad actually. This is negative 32. And 5 times 2 is 10 is 0. This is 1. 5 times 3 is 15, 16. Negative 160. That's the value of G6. Over here, we are given the common ratio, but G2. So it's fine. We need to do 2 steps. So let's plug in n as 2 over here. So G2 will be equal to G1 R raised to n minus 1. Sorry, 2 minus 1, right? Because n is 2. G2 is 8. G1, we don't know. R is 1 half and 2 minus 1 is 1. 1 over 2 raised to 1 is just 1 over 2, and multiplying 2 both the sides, it will be 16. 16 is equal to G1. Okay. So Gn is going to be G1 times, G1 is 16. I'm just going to plug in 16 here. So 16 times 1 over 2 raised to n minus 1. This is the general term. And they need G6. So once again, I'm just going to put that as 6. Okay, need some space. All right. G6 is going to be 16 times 1 over 2 raised to 6 minus 1. So 16 times 1 over 2 raised to 5. 2 raised to 5 we just found, right? 32. So 16 over 32, which is just 1 over 2. Well, that's nice. G6 is 1 over 2. Okay, this will be interesting because this needs some more effort. So uh, first we are going to use that twice. So the general form is Gn is equal to G1 R raised to n minus 1. So G2 will, why 2? Because G2 is given. So G2 will be equal to G1 R raised to 2 minus 1, which is G2 is equal to G1 R. Let's box this up. And then I have G5 is equal to G1 R raised to 5 minus 1, which is G1 R raised to 4, right? This is the other. And by the way, what is G5? That's 27. And what is G2? That's 1. Okay. And all such questions of geometric sequences, it is encouraged to divide these. Because if you just divide this, obviously you can use elimination like find G1 in terms of R and put G1 over here. I personally feel like division is pretty easy. What I mean by division is you take this equation. I'm taking this one first because it has a higher power of R. So, and you divide these both. So when you divide, the left sides will be divided like 27 over 1, and the right sides will be divided. So 27 will be equal to R raised to 4 over R is R cube. And if we take cube root both the sides, then cube root of 27 is just 3. Not just 3, right? Not plus minus 3. So R is 3, and we need G1 as well. So let's plug in this R as 3 over here. So that will look like 1 is equal to G1 times 3, which means that G1 is 1 over 3. So I have G1, I have R, so that's about it. I have the general equation as Gn is equal to G1 times R raised to n minus 1. So G6 will be 1/3 of 3 raised to 6 minus 1 is 5. 3 raised to 5 over 3 is just 3 raised to 4. And 3 raised to 4 is 81. So these are our final answers. Right, I think similar situation over here. It's just that we have fractions. So G4 will be equal to G1 times R raised to 4 minus 1, which means that negative 12 is equal to G1 R cube. That's 1. Then G7 is equal to G1 R raised to 7 minus 1. So 32 over 9 is equal to G1 R raised to 6. Well, that's equation 2. Let's divide. So I'll take this one first because that has a greater power. So left sides are 32 over 9 and negative 12. And the right sides are G1 R raised to 6 and G1 R cube. These two will be gone. And the left side is going to look like 32 divided by this 9 drops down and multiply with negative 12. Actually, you know what? I'm not going to multiply. I'm just going to keep it like negative 12 multiplied with 9 is equal to R raised to 6 over R raised to 3 is just R cube. It can be simplified, right? 4 times 8 is 32, 4 times 3 is 12, and 9 times 3 is 27 with a negative sign. Well, that turns out to be a good number actually, because I can find the square root of both. I'm sorry, cube root of both. Cube root of 8 is 2, and the cube root of negative 27 is negative 3. Now, that's nice. R is 2 over negative 3, or just negative 2 over 3. That I'm going to plug in here, or you can plug in here, your choice, but I will pick this one because it's a smaller power, so let's work. I hope so. So I'm going to get negative 12 is equal to G1 times negative 2 over 3 cube. So negative 12 is equal to G1 negative 8 over 27. 4 times 2 is 8, 4 times 3 is 12. So let's cross multiply. In fact, double these two negatives are also cancelled. I hope you're following. So I have 27 multiplied with 3, which is 81, is equal to G1 times 2. So G1 is 81 over 2. So the equation that we have is Gn is equal to G1, which is this, and common ratio, which is this, raised to n minus 1. And if you want to find G6, then we're just going to write here, G6 will be equal to 81 over 2, negative 2 over 3, 6 minus 1 is 5. I'm not going to simplify that. It's fine if we leave it like that. So that's our final answer. Finally, graphs over here. So this one is G1 is equal to 1. And this one is G4 is equal to 3. And this one is G7 is equal to 9. Okay. Well, we have G1, but we need to figure out what the common ratio is. So for that, I'm going to use probably this one. So I'm going to say G4 is equal to G1 times R raised to 4 minus 1. G4 is already 3, so 3 is equal to G1 is 1, R cube. Really? Well, that's definitely not at all pleasant. I'm just making sure I've not made a mistake. Doesn't feel like that. Okay, then R is 3 raised to 1 over 3. Who likes that? So the general equation is going to be G7 is equal to G1, which is just 1, times R, which is this, raised to n minus 1. Just going to box this in, and G6 is going to be 3 raised to 1 over 3, and 6 minus 1 is 5. So this is 3 raised to 5 over 3. Oh my goodness. Okay. Right, so this is interesting because finding common ratio will not be a problem here because we know two consecutive terms. This is G1 equal to 6 and this is G2 equal to negative 3. This is G3 equal to something, I don't care. This is G4 equal to something, this is G5 equal to something, because I don't want to estimate. I don't even need that because I have G1, that is 6. I need that. And I need the common ratio, which is just the ratio of two consecutive terms. And I know that these are two consecutive terms. But remember, latter over former. So negative 3 over 6 is negative 1 over 2, and that's about it. The equation is going to be Gn is equal to G1 R raised to n minus 1. That's Gn. And G6 is going to be 6 times negative 1 over 2 raised to 6 minus 1 is 5. 2 raised to 5 is 32 with a negative sign, so negative 6 over 32. I think it can be reduced. Negative 6 over 32 can be reduced as negative 3 over 16. That's G6. That's the answer, right?